Your task for today is to complete this 20 question grid. The topics are the same as the one from 2 weeks ago, however the questions are slightly different. The grid is attached to Show My Homework in the Resources to Help You section along with the answers. Make sure you write down all you're working out as you go along. Once you have finished, simply take a photo and upload your work to Show My Homework so I can see how you've got on with the task. I have added the video explanations for each type of questions at the end of this video for your convenience. Question 1 is always about solving inequalities, and you can solve an inequality just like you would an equation. So this particular one here, we have 7 is less than 2x minus 1. Imagine this was an equal sign and we were trying to solve an equation. What would we do? We'd start off by adding 1 to both sides. That would give us 8 is less than 2x. And then lastly, to get x by itself, I would divide both sides by 2. That gives us that 4 is less than x. Now that has therefore solved the inequality. However, sometimes we like to write the x at the front. So just bear in mind that it's saying that 4 is less than x. So if I was to swap this round, that means that x is greater than 4. So notice how the inequality sign switches. Both of these answers are perfectly fine. Question 2 will always ask you to expand and simplify some brackets. In order to do this, we need to know two things. First of all, how to expand the brackets, and secondly, how to collect the like terms together at the end and simplify this answer. I'm going to start by writing the question out again. So we have 4 lots of 2x plus 1, and we want to add to that 3 lots of 2x plus 1. Now first of all, if I split the question down this line here, hopefully you can see that on the left side we have a single bracket that we can expand, and we also have a single bracket on the right hand side that we can expand as well. Let's start on the left hand side. So we have 4 on the outside. We want to times this by everything inside our bracket. So 4 times 2x gives us 8x, and 4 times positive 1 gives us positive 4. That's the left side done. On the right hand side we have positive 3 at the front. Please just be careful to have a look at this sign here, because obviously if it's negative you have to think about the rules of timesing by negative numbers. So in this case we have positive 3 times by 2x, that gives us positive 6x, and then we have positive 3 times by positive 1, which gives us positive 3 at the end. Now for this particular one I've written this positive sign here because essentially we're going to want to collect these like terms together now and simplify them. So first of all, looking at our x terms just here, we've got 8x plus 6x. Again, think really carefully about what the signs in front of your terms are. 8x plus 6x gives us 14x's in total, and then likewise we've got positive 4 and positive 3. If I have positive 4 and add 3 to it, I end up with positive 7. So that's my answer, 14x plus 7. The third style of question will always be a mixed number calculation. Now this could be adding, subtracting, timesing or dividing. I'm going to look at subtracting and dividing, and hopefully that will cover all the skills that you need to perform the other two as well. So firstly we want to have a look at either adding or subtracting fractions. Now there's two things you want to do to start off with. First of all is to take your question, which in this case is 3 2/3 subtract 2 1/2, and I want to turn both of these numbers into improper fractions. That would give us 11/3 take away 5/2. The next step we want to do is make a common denominator. So I think with 3 and 2 at the bottom, 6 is the best number to have at the bottom. Meaning this first fraction I'm going to need to times by 2, and the second fraction I'm going to have to times by 3 on the top and the bottom. That gives me 22/6 for my first fraction, and times it by 3 gives me 15/6 for my second. And now, because I have a common denominator, I can simply subtract 22 from 15 to get 7, and my denominator stays the same. So my answer is either 7/6, or I can write that as 1 and 1/6 if I want to put it back as a mixed number. If we're asked to times or divide some mixed numbers, like in the second question, the process initially is very much the same. So 1 4/5 divided by 1 1/2, we're going to begin by writing both of these mixed numbers as improper fractions. That would give us 9/5 divided by 3/2. Now, unlike adding and subtracting, it doesn't matter if our denominators are different. A common misconception is to make these the same, and whilst you still get the same answer, you'll have to do a lot of cancelling out at the end. So please don't think you need to do that. Now, because this is a divide question, we're going to apply the KFC method. KFC essentially means keep, flip, change. So if we're dividing two fractions, we keep the first fraction the same as 9/5. We flip the second fraction over, so instead of 3/2 it becomes 2/3, and we change the divide to a times. And when we're timesing two fractions together, we simply times the top two numbers, which gives us 18, and times the bottom two numbers, which gives us 15. So 18/15 is my answer. Now, unlike the previous one, a factor of 3 can be divided both out of the top and the bottom, so I can simplify this to 6/5, and that is the same as 1 and 1/5. Question 4 will always be about decimal multiplication. Now, in terms of working out a decimal multiplication, I'd first suggest thinking about what the question would be without decimal places in. So in this particular case, we'd get 235 times by 24. I'd work out what the answer to that is. So let's do this now. Five times 4 is 20, 4 times 3 is 12, plus the 2 is 14, and 4 times 2 is 8, plus the 1 is 9. Need to add a 0 because we're now multiplying by 20, not just 2, and therefore 2 times 5 is 10, 2 times 3 is 6, plus the 1 is 7, and 2 times 2 is 4. Adding all of these up, we get 0, 4, 16, and 5 at the end. So my answer is 5,640. Now, in terms of converting this answer here into something that's equivalent to this answer to the question we had initially, we simply need to think about how many decimal places we had in our question to start off with. We ignored 3 of the decimal places, so I need to take my answer, 5,640, and I need to add 1, 2, 3 decimal places to my answer. So therefore my answer is 5.64. The fifth sort of question that you could get asked is a decimal division. In our particular case, the divisor of our question is always going to be a decimal. It's much easier for us to work out if we can make this a whole number. So I'm going to start off by writing the question 40 divided by 0.8. However, I've written it in a fractional format like this. We want the denominator, the number we're dividing by, to be a whole number, and we can get that by timesing the top and bottom by 10. So doing so gives me 400/8. 400/8 is just another way of saying 400 divided by 8. And what you'll notice is we've rewritten this question in a format that is equivalent, is equal to, so whatever the answer to this is exactly the same as whatever the answer to this is. So all we need to do now is work out what 400 divided by 8 is. Now if you're struggling with that, remember you can always use your bus stop on an 8 on the outside and 400 inside. 4 divided by 8 is 0, remainder 4. 40 divided by 8 is 5. And 0 divided by 8 is 0. So that gives us an answer of 50. 50 for 400 divided by 8. and 50 for our initial question, 40 divided by 0.8, because they're equivalent. Question number 6 is always a question on simplifying surds by adding or subtracting them. To help us understand this question and how to simplify them, I'm going to rewrite it, but thinking about it if it was an algebraic question. So instead of 5 root 3, I'm going to write 5a. Instead of root 3, I'm going to put an a again, and then I've got a plus 3 at the end. If we were asked to work this out, we know that 5a plus a would be 6a, and this plus 3 at the end we would keep separate because there's no a terms in it. So we'd say 6a plus 3. In terms of working this out with surds, the same thing applies. Because they both have root 3, we can add those terms together. So 5 root 3 plus another root 3 would give me 6 root 3, and this plus 3 at the end would stay separate. That would be my final answer. Now, they could make this question more difficult. They could have said, what is root 75 plus root 3 plus 3? That in fact means the same thing, but the only additional step that you have there is that you need to take this root 75 and simplify it. Now, in order to do that, if you do get a question like this, you want to take out the biggest square number factor of 75 that you can think of. So in this particular case, it's root 25. What's left over if we take out that 25 factor is 3, and we can work out that the square root of 25 is 5, which gives us 5 times by root 3, and therefore 5 root 3 would be the simplified version of root 75. So you can see how this is the same question. 5 root 3 just here, plus root 3 plus 3 is the same as what we started off with. The 7th sort of question that you'll get is always to do with your laws of indices. Now, there was 3 main laws that you need to remember for this. One is when we times, one when we divide, and one is a power of a power. So let's remind ourselves what they are. If we have a to the power of n times a to the power of m, because the base number here is the same, we can say that we get a to the power of n plus m. We essentially add the powers together. Our second law is if we have a to the n divided by a to the m. Now again, because this base number here is the same, it remains the same in our answer, but this time because we're dividing, the powers of a are cancelling out, and therefore we subtract. And lastly, we have a power of a power. So let's say we have a to the power of n to the power of m. In this particular case, the base of a remains the same, but the power becomes n times m. Relating this back to our question, we have a to the 4 times by a squared. Now, because we're timesing, it's very much like this first law here where we add the powers. So this is the same as a to the power of 4 plus 2, and we know that 4 plus 2 is 6, so a to the power of 6 is our answer. Question 8 will always ask you to convert one metric unit answer into another. In our particular question, we want to go from 1 centimetre squared into millimetres squared, which is a little bit more complicated than it initially seems. We first need to remember and recognise that 1 kilometre is the same as 1,000 metres. We need to know that 1 metre is the same as 100 centimetres, and also 1 centimetre being the same as 10 millimetres. Now, the one that we're going to need to use in our question is this one just here. However, depending on the questions that you have, you might need one of these 3 metric conversions. Now, in order to help us visualise this problem, I'm going to draw 2 squares. One square is going to be 1 centimetre by 1 centimetre, and we therefore know that the area of this would be 1 times 1, which is 1 centimetre squared. Notice how that is the same as what we have in our question. Now, if I wanted to convert this answer into millimetres, let's think about what would happen if I was to change my lengths. We know that 1 centimetre is the same as 10 millimetres. That therefore means that our area is going to become 10 times by 10, which is 100 millimetres squared. Now the reason that this has happened is because we are changing not only millimetres on one of the lengths but both of them, so we're actually timesing by 10 in 2 dimensions. So let's say for instance I had 3 meters squared and I wanted to convert that into centimetres squared. Well, what I would need to do is say, first of all, to get from meters to centimetres I times by 100, but because I'm going to do that in 2 dimensions I'm going to times by 100 squared, so that's going to be 3 with 1, 2, 3, 4 zeros on the end. Question 9 is about rearranging and changing the subject of a formula. In this particular case we want to make x the subject of y equals ax squared plus b. Now let's just have a think about the order of what we've done to x. We started off with x. The first thing we will have done is squared it, then times it by a afterwards, and then plus b to it. So when we reverse it we want to do that but in the opposite order. So I'm going to start off by taking b from both sides. That would give me y minus b is equal to ax squared. Next I want to divide both sides by a. That would give me y minus b over a, and that is equal to x squared. And the final step is obviously to get rid of the squared by square rooting both sides. So the square root of y minus b over a is equal to x. Please take care to think about the order that you did certain things in and how you're going to reverse that, because it's very tempting to square root or divide in different orders, and obviously if you do it in the wrong order you get the wrong answer. The last question will always ask us to work out either an area or circumference of a whole circle or part of it. So the first thing that we need to remember is those 2 formulas, which is the area of a circle is pi times by the radius squared, and the circumference is pi times diameter. Now first thing I would always do is have a think about what both the radius and diameter is. That way we're ready to answer either of the questions, and it also helps us to think about what we're given in the question. So I know that the radius of my circle is 5 and also the diameter is going to be 10, the diameter being the distance all the way across. Now my question asks me to calculate the area of this circle and it wants my answer in terms of pi. So therefore I can say that the area is pi times by the radius, which is 5 squared. This therefore gives me pi times 5 squared, which is 25, and this therefore means my answer is 25 pi. Now if you want to be really good, remember your units, which are centimetres squared. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.